What do Heisenberg's uncertainty principle and a 2,000-year-old paradox have in common? Let's find out. Quantum mechanics is weird. It says that if you take the physical laws that govern the normal-sized universe and shrink them down to the subatomic level, that they just stop working. The single most important quantum physicist is Werner Heisenberg, and the single most important law he created is called the uncertainty principle. It says that if you take two related physical variables, like position and momentum, then you can never perfectly pin down both at the same time. If you isolate one, the other will escape your grasp, by physical necessity. Now, this seems like some pretty cool, new age, cutting edge physics, and it is, but it actually has a parallel back in ancient Greece. The philosopher Zeno lived in the 5th century BC, and he's best known for his paradox Achilles and the tortoise, but that's a thought experiment for another day. Today, we're going to talk about the arrow paradox, in which Zeno argued that motion is impossible. So here's the setup. You are shooting a bow and arrow, and I am sitting on the sidelines being pedantic and annoying. You fire your first arrow, and I say, when you fired that arrow, where was it? You say, I don't know, it was somewhere between my bow and the target, and I say, no, where was it exactly? After seeing your blank stare and a moment of awkwardness, we decided to just gather a little bit more information. We set up a remote camera that will show us exactly where that arrow was. So you fire another arrow, and these are the frames that the camera gives us back. But interesting, this isn't an arrow in a definite position at all. It's probably just a problem with the shutter speed, so let's crank that all the way up as far as we can possibly go and then take another picture. In this picture, we actually do have the exact position of the arrow, but here's where Zeno's paradox comes in. The arrow is only in that exact position, and while it's in that position, it isn't moving. In Zeno's words, what is in motion moves neither in the place it is, nor in one in which it is not. Or more simply, if we know where the arrow is, it's not moving, so therefore, motion is impossible. Of course, Zeno knew that this wasn't actually the answer. He knew that the arrow was moving, he saw it just like the rest of us, but he wanted to explore what motion really was. And interestingly, I think that his insight about motion isn't actually all that different from the insights that we get from quantum mechanics. Think about it. Here are our two choices of pictures for the arrow. In the first, we have good information about the momentum of the arrow, but a very poor understanding of its position. And in the second, we have good information about the position, but bad information about the momentum. It might as well drop straight down in the next frame. The question then is obvious. What shutter speed should we choose in order to capture perfect information about both the arrow's position and about the arrow's momentum? The answer is, we can't. Just like in quantum mechanics and the uncertainty principle, in Zeno's ancient Roman paradox world, we can't capture perfect information. There's some amount of uncertainty that we just can't escape. If you want to learn more about how this quantum stuff actually works, then I strongly recommend you check out 3 Blue 1 Brown's video. He does an awesome job drawing parallels between the uncertainty principle and not just photography, but also music and Doppler radar. It's an awesome video. But for now, I hope that you enjoyed this little curiosity. Maybe the next time that you're outdoors with your outdoorsy friends shooting bow and arrows, you can tell them about this and they'll think it's cool. Maybe not, but maybe. I'll see you next time.